So the last part of section 10.2 is looking at paired data. And it says study designs that involve making two observations on the same individual or one observation on each of two similar individuals. This results in what we call paired data. And when paired data comes from measuring the same variable twice, we can make comparisons by analyzing the difference between each pair. And if those conditions for inference are met, we just have to use a one sample t procedure to find the mean difference. So we're not using, it's not two samples, it's one sample being tested twice. So this is why we call it paired t procedures. And so some examples of things that might be considered matched pairs, like if we looked at adopted twins, one went to a high-income family, one went to a low-income family, and then doing an IQ comparison between the two. Having students try to take a multiplication test to look at their score as compared to when music was playing and without music was playing. Testing salmonella in 10 different eggs, but testing it two ways. So you have one sample, but you're doing two procedures on it. So when you have paired data, the formula for finding the interval, they're similar in format, but you'll notice the variables are just represented a little bit differently. It'll be the mean difference, and this just means the difference between them. So you're not working with the two separate sets of data. You're gonna find the difference between them, and you're only working with that set of data. And then the times your t critical value, and then it's your standard deviation difference, the difference between your standard deviations over the difference between your sample size and square rooting that. And here's how you can find your test statistic if you're doing a significance test. And again, every time you see this diff, that just means you're looking at the difference between them. So let's walk through a confidence interval. So it says a research studied a random sample of identical twins who had been separated and adopted at birth. In each case, one twin, twin A, was adopted by a high-income family and twin B was adopted by a low-income family. Both twins were given an IQ test as adults. Construct and interpret a 95% confidence interval for the true mean difference in IQ scores among twins raised in high-income and low-income households. So if you go to the next page, here's your data, okay? Now, they show twin A and they gave their IQ scores, and then twin B. I went ahead and I calculated the differences and put that over the top because this is really what you're going to work with. Now, obviously these numbers were pretty easy to subtract in my head and just kind of do along the top. However, if you ever have values that are a little more difficult to subtract and it's going to take you a while, what you can do is on your calculator, enter your first set of data in list 1 and your second set of data in list 2. What you can do is in list 3, you can have it do all the subtraction for you. All you have to do is, is go up and highlight L3. And then down at the bottom, you can put in formulas. And we want to do L1 minus L2. Now, L1 and L2 are located on top of your 1 and 2 buttons. So you just hit second 1 minus second 2, and it's giving you a formula, and when you hit enter, it puts in all those differences for you. I think I typed something wrong. Hold on, let me adjust. This was supposed to be 116. Let's see. There we go. Now our message. But you can have this do the differences for you. Like I said, this one was pretty easy to do. Apparently it was harder for me to type it in than it was to subtract. But you can go ahead and have this do your differences for you. And now, if we use the calculator, we just need to remember that our differences are in list 3, so it will take care of that for us. So if we were to go through our confidence interval, so we're only going to have one parameter here. We're looking at the mean difference. And so this represents the true mean difference between twin A and twin B in IQ scores when they were raised in separate households. We need to check our conditions in the same way. It did state that they were a random sample Normal, our sample size was only 12, which is less than or equal to 30, so we would need to provide a plot of our difference data. Whether you do that as a scatter plot or a histogram or a box and whisker, you would need to provide a plot on this one. And then independence, we can assume it's likely true that a sample of 12 identical twins is less than or equal to a tenth of all twins raised in separate households. Okay, so the name of this test, it's just called, it won't say 4 differences on your calculator, it just says T interval. And we can use that to find our confidence interval. So on your calculator, again, it's located in the same place. You'd go to Stat, go over to Test, and you just want T interval, which is option 8. Okay, now, we actually have data, and remember, you want to work with the differences. So where this, right now it says L1, our differences were in L3, so we need to just hit second 3. Frequency can stay at 1, our confidence level is correct, and then we just hit calculate. And here is your confidence interval. And it also gives you the mean difference and the mean standard deviation should you want to set up some work with the formula you have. Again, I would run this first, and then you can get all the values from here. But if you name the test, we can just go directly, we can use the formula and just go directly there. And so we would say we are 95% confident that the interval 3.338 to 8.3287 captures the true mean difference in IQ, looking at high to low income, among identical twins raised in separate households. And so you can kind of see also, if you just kind of do some interpretation, all of these values are positive, which means there likely is a difference. If we were to do a significance, we would probably reject the null, that there is no difference. There definitely is a difference that if you're raised in a high income family, your IQ is higher, just based on this. So if you are going to do a significance test, again, you're just working with the differences. So if we look at this example, it says researchers designed an experiment to study the effects of caffeine withdrawal. They recruited 11 volunteers who were diagnosed as being caffeine dependent to serve as subjects. Each subject was barred from coffee, cola, and other substances with the caffeine for the duration of the experiment. During one 2-day period, subjects took capsules containing their normal caffeine intake. During another 2-day period, they took placebo capsules. The order in which subjects took caffeine and placebo were randomized. At the end of each 2-day period, the test for depression was given to all 11 subjects. Researchers wanted to know whether being deprived of caffeine would lead to an increase in depression. A higher value equals higher levels of depression. So if you go to the next page, you can see the data. All right. Now this example was nice. They calculated the differences for you. And so you would not need to take care of that. You could just enter these into list 1. And so our parameter would be the true mean difference between placebo and caffeine in depression score. All right. Our hypothesis is we suspect that the mean difference would be 0, that there is no difference in depression score, whether you got the placebo or caffeine. But what we suspect is happening is that difference is going to be positive. We're kind of expecting to see that when you get the placebo, your depression score may be higher. And so we're looking at that mean difference as being positive, okay? Or that the mean difference is greater than 0. If we check our conditions, the random condition, again, this was an experiment, so we need to state it was randomly assigned. We meet our 10% condition since it was randomly assigned. A lot of times this allows you to assume that the groups are independent since there was random assignment. And then normal, since 11 is less than or equal to 30, we would have to provide a sketch of our difference values. Okay? Now, this is just like, it's just called a T interval with confidence interval. It's just called a T test on your calculator. All right? And again, if you look for your values, you would just go stat and go over to tests. T-test is option 2. You can put in data or stats. We would put in data. Our assumed mean difference is 0. We would, if you put your data in list 1, you'd change that to list 1. And then we are doing a greater than test, and you just go down to calculate. And I listed the t-value it gave me here. I listed the p-value it gave me, which is 0.0027. And since 0.0027 is less than 0.05, we would reject the null. So we do have convincing evidence that depriving subjects of caffeine does increase your depression score. So for your assignment today, I would definitely finish the book problems first. The substitute will be giving you a worksheet. The worksheet really just covers paired data, except for the last question. That's having you kind of look at a bunch of different situations and really decide which procedure out of chapters 8, 9, or 10 would be the best. So you might want to have that blue kind of inference summary sheet out. That might be helpful for you as you work that last problem in the worksheet. If you do have questions, I will be back this afternoon. Please feel free to stop by. Otherwise, tomorrow is a work day and we can answer any questions then.